You're welcome to day 43 of 50 days of tutelage. In today's class, I will be continuing with trigonometry. In the previous class, I had taught you about how to measure angle and also the application of SOHCAHTOA and CHOSHAHCAHTOA and so many other things that entailed as well. I gave you all the quadrants, first quadrant, second quadrant. So if you missed that class, just use the link that is popping up right away to check out the first class. So what am I going to be teaching you in today's class? I'll be introducing you to some basic trigonometry identities. Then we'll talk about the sine rule and the cosine rule. Then we'll look at the area of a triangle as well. So these are the three things I'm going to be discussing majorly in today's class. So let's start with trigonometry identities. There are a lot of them, a lot of trigonometry identities, but I'm going to be basically talking about just three of them in this class. We have the Pythagoras theorem, and the Pythagoras theorem simply tells us that the square of the length of the opposite side plus the square of the length of the adjacent side is equal to the square of the length of the hypotenuse squared. So to generate these trig identities, what I'm going to do is that I'm going to divide, for the first case, I'm going to divide everything through by the square of the hypotenuse. So divide everything through by the square of the hypotenuse. So permit me to just be using h. So I'll be using O for opposite, I'll be using A for adjacent, and I'll be using H for hypotenuse. So divided by hypotenuse squared. Now, so what you notice here is that hypotenuse squared can cancel out hypotenuse squared. And here you have opposite divided by hypotenuse, all squared, plus adjacent divided by hypotenuse, then all squared. And this is going to be equal to 1. So don't forget, earlier in our SOHCAHTOA and CHOSHAHCAHTOA, so we have SOHCAHTOA, so we had already explained this in the previous class, and CHOSHAHCAHTOA. Now, we know that when we have opposite divided by hypotenuse, that is our sine. So therefore, this is going to be sine theta, all squared, plus adjacent divided by hypotenuse, that is cosine. So we have cosine theta, all squared as well, equals 1. So therefore, we have sine squared theta plus cos squared theta equals 1. So whenever you see something of this nature in trigonometry, sine squared theta, cos squared theta, it means you will evaluate the sine of that angle, then you square the result. So if I say, what is sine squared 30 now? So the first thing you need to do is that you evaluate sine 30. Sine 30 is 0.5. Then you square it. That is exactly what you're expected to do when you are doing sine squared of something. The only exception is when you have sine raised to power negative 1. This is not the same thing as this. So sine theta raised to power negative 1 is not the same thing as arc sine theta. This actually means sine inverse, arc sine, and this one means 1 inverse of sine. They actually, arc sine is different from the inverse of sine. The inverse of sine is cosec. So this literally means 1 divided by sine theta. And this one means what is the inverse. So if I'm to get this answer as the sine of something, what angle would produce that? I will still talk about that later in this video. So this is the first one I want to show you. The first trigonometry identity I want to show you, that when you pick an angle, theta, now when you find the sine of that angle, you square it. You find the cosine of that angle, you square it. When you add them together, the answer will always be equal to 1. That's the first trig identity. So the same way, I'm still going to use the Pythagoras theorem. So using the fact that opposite squared plus adjacent squared equals hypotenuse squared. I divided through by hypotenuse earlier. So what if I divide through by opposite this time around? So I have divided by opposite squared, divided by opposite squared, divided by opposite squared. Of course, this will become 1 plus, now this will become adjacent divided by opposite, all squared, and this will become hypotenuse divided by opposite squared. So this will be 1 plus, now what is adjacent divided by opposite? So that is our inverse trigonometric function. That is cow, and that is cotangent. So this is cot theta, then square. Then what is h over o? That is hypotenuse divided by opposite. That is the inverse of sine, which is cosec. So cosec theta all squared. So another trig identity will be that 1 plus cot squared theta equals cosec squared theta. And for the last one, we still have opposite squared. We still have opposite squared plus adjacent squared equals hypotenuse squared. So this time around, I've divided through by hypotenuse, I've divided through by opposite. So let me divide through by adjacent now. So divide through by adjacent squared, divide through by adjacent squared. So this is going to be opposite divided by adjacent squared, plus this is going to be 1, and this is going to be hypotenuse divided by adjacent squared. So if you look at your Choshakawa and Sokatwa, opposite over adjacent, that is tangent. So this is going to be tan theta, and that's going to be squared, plus 1 equals, so what is hypotenuse divided by adjacent? That is sha, and that is going to be sec theta all raised to the power of 2. So therefore, you have another trig identity that tan squared theta plus 1 equals sec squared theta. Like I said, there are so many other trig identities, but these three, I'm going to focus on these three for this particular class. And then you can always manipulate these things around. For instance, here you have that the first one, we have that sine squared theta plus cos squared theta is 1. So that implies that you can express that sine squared theta is the same thing as 1 minus cos squared theta. And that implies that sine theta is the same thing as the square root of 1 minus cos squared theta. So this can actually be used in so many ways. Just take note of the general form, and that's that about that. So that's for trig identity. Of course, we have a lot of other trig identities, but I'm going to be talking about something else now. So let's go further. Now let's talk about sine rule. Sine rule. So what is the purpose of sine rule actually? This sine rule is what we use to determine some sides of a triangle or some angles of a triangle that are unknown. For instance, if I give you a model triangle like this, so let's say you have this triangle, and then this triangle has such that this side is label A, this side is label B, and this side is label C. The immediate side that is facing each of the angle, each of the vertices, let's call them the small, let's use small letters for them. So if this is A, this will be the side that is facing A. If this is C, this will be the side that is facing C. And if this is B, this will be the side that is facing B. So here's the thing. Any of these B, C, or A, or this A, B, or C can be unknown. How do we solve for them? Sine rule is one of those rules that actually help us solve for them. So the sine rule, generally, we have A divided by sine of A equals B divided by sine of B equals C divided by sine of C. By the way, some people like to use it as inverse, that is sine A divided by A. Whichever one you decide to use, it's still going to be the same thing. So what we do is that we isolate any pair in this case. So that is, we can choose these two. We can choose to work with these two. We can choose to work with these two. And then we can choose to work with these two. That is, this and this. Anyone that you decide to choose to work with there, all you have to determine is that. So let's look at it very well. I'm just going to isolate one now. So if I choose to work with A divided by sine A equals C divided by sine C. This is a single equation. And one thing we know about single equation is that for you to be able to solve them, there can only be one unknown in that place. So that implies that in this situation, is that you know this side and you are looking for this angle. So automatically, this side and this side has to be given. So we realize that whatever you are looking for, you must have at least one side given, followed by the corresponding angle. So this is very necessary before you can use sine rule at all. The length of a side must be given, followed by a corresponding angle. Then, when you are done with that, the side you are looking for, if you are looking for a side, the corresponding angle of that other side must be given as well. So this is it. You have been given a side and its corresponding angle. That's the first checklist. The second thing is that if you're looking for a side, if side is what you're looking for, you must have the corresponding angle. And if you're looking for the corresponding angle, you must have the side to be given. So the side, if you're looking for the angle, the corresponding side must be given. So that is why if you're looking for A now, the angle A must be given. If you're looking for angle A, then this A must be given as well. So, but there's something important I want to tell you about sine rule, is that oftentimes when you solve this thing, you can actually have two possible solutions. In the last class, I was able to establish that when you have like angles that are beyond 90 degrees, so for instance, angles like 150 something, 170 something, but they are less than 180 degrees, this guy belongs to a quadrant we call the second quadrant. And because they belong to the second quadrant, then we can always send them back to the first quadrant using sine 180 minus theta. So it implies that sine 180 minus theta is going to be the same thing as sine theta, because sine is also positive in the second quadrant. So sometimes when you get the value of an angle, you can actually get another angle as well. The only way you check if this is true is that you need to sum up all the entire angle in the old system. If the sum of the angle exceeds 180 degree, then you leave one of those values alone. So what I mean is that, so let's say for example now, I'm solving a triangle. So this is the triangle I want to solve. Then I have this side. Let's say this side is 3 and this side is 30 degrees. And let's say this side is, let's say 10. And I'm looking for this particular angle right here. So I can use sine rule here. So all I have to do is 3 divided by sine 30 degrees will be 10 divided by, so let me just call this one alpha, divided by sine alpha. So that implies that 3 sine alpha equals 10 sine 30. So that implies that sine alpha equals 10 sine 30 will be 5, and that will be 5 over 3. So unfortunately, I cannot have that. So 5 over 3 is not possible. The reason why this is not possible is because I cannot have any sine of an angle greater than 1. And 5 over 3 is greater than 1. So this is actually not a possible triangle. So permit me, I'm just going to flip it like that. So this is going to be the 10, and this is going to be the 3. So that implies that this whole thing will change now. Everything here will change. Everything will change. So we have this now. So we have 10 divided by sine 30, then 3 divided by sine alpha. So that implies that 10 sine alpha will be 3 sine 30. So 3 sine 30 will be 1.5. So that will be 1.5 then divided by 10, and that will be 0.15. So now alpha will now be equal to the arc sine of 0.15. So it's what I'm talking about now. So I'm looking for the angle alpha such that when I press the sign of alpha, I'm going to get 0.15. So I'm going to press this on the calculator, arc sine 0.15. And this actually gives me 8.63 degrees approximately. But here's the thing. This is not the only angle that will give me 0.15. I can also just subtract this from 180 degrees. 180 minus 8.63 degrees. That will give me, so 180 minus 8.63 degrees. That is 171.37 degrees. So what I'm saying is that if you press on your calculator right now, if you press sine 171.37, it's going to give you 0.15 approximately. And if you also press sine 8.63, both of them will give you the same result. So that's what I'm trying to say. When you're using sine rule, it's possible that you can actually get two angles. But what will make one angle useless is that you realize that if you add this 171 plus the 30 that already exists, the result will be more than 180 degrees. And take note of the fact that there is even still another extra angle here that we don't know about. And some of the angles in a triangle will be 180 degrees. So in this situation like this answer will not hold. Even though it is a possible solution for alpha, but it will not hold, because by the time I use such result, it's going to be what? It's going to be make the sum of all the angles in this place to be greater than 180 degree. So therefore, that one is cancelled. So now that is that about sine rule. Let's talk about the cosine rule now. So cosine rule. So I'm going to use the same triangle that I used earlier. So I'm just going to go ahead and copy and paste it. Will I be able to copy everything? I think I can. I'm just going to start from here. Yes, that's it. So to use the cosine rule, I'm going to just state it out for you. So this says that a squared equals b squared plus c squared minus 2bc multiplied by the cosine of a. So this is a pattern. You can actually use it to solve for b or to solve for c. So what you notice here is that if I want to look for side A, these are the conditions. If I'm looking for any side, I must know the value of the two other sides. That's the first thing. You must know the value of the two other sides. Then you must know the angle that corresponds to the side you are looking for. So when you're looking for a side, the first thing is that you know the angle that corresponds to it. And you must know the length of the other two sides. So that is how you use cosine rule. What if I'm looking for the angle? The same thing. If you're looking for angle A, you must know the side, the length of the side that corresponds to it. Then you must know the length of the other side as well. So meaning that even when I want to use sine rule or cosine rule, one thing is always certain. Whenever I pick a side, I must know the angle that corresponds to the side. So if I'm looking for an unknown A, whatever other side I'm picking, I must know the corresponding what? Angle that is there. So that is for sine rule. But for cosine rule now, so if I'm looking for B, I must know angle B. If I'm looking for angle B, I must know side B as well. So that is exactly the way it works. In sine rule as well, if I'm looking for A, I must know angle A. If I'm looking for angle A, I must know side A. So you cannot look for one parameter without their correspondence. So meaning that if you're looking for a side, you must have its corresponding angle. If you're looking for an angle, you must know its corresponding side. And that is the way it works. So this is cosine rule. And then you can just use the same example I gave here to solve for it. You'll still get the same result. And basically, you can I'm not going to do any further example here because of time. So if you want to solve for angle in this place, all you have to do is just put everything inside. So let me just help you with that. If you take everything here, let's say you bring all this negative 2bc cos A to the other side. So you have 2bc multiplied by cos A. That will be equal to b squared plus c squared. Then a squared will become negative a squared. So you can isolate the cosine here. So you divide both sides by 2bc. And that would imply that cos A equals b squared plus b squared minus a squared divided by 2bc. Why do I keep saying 2bc? Maybe I need 2 Bitcoin. Well, I don't know. Now, so this is cos A. Now, to find out, you just find the cos inverse of both sides, and then you get your result for A. So that's that for that. So I listed that. I'm going to talk about trig identities. I've talked about that. I'm going to talk about sine and cosine rule. So finally, let's talk about areas of triangle. Areas of triangle. So let me put this here. Now, the basic one I'm going to be talking about, I'm not going to be talking about the one that does not involve angle. I'm only going to be discussing the one that involves the use of angle, because I reckon that you're all familiar with all these things already. So, but the first thing I want to talk about is that, you see, whenever you are looking for the area of a triangle, I know you know that the basic formula is half base times height. So if the basic formula is half base times height, but most of you don't really know how to determine the half base times height. The mistake you usually make is that you think whatever is down is the base. That's not the way it works. Anything can actually be the base. This B can be the base. This C can be the base. The only thing that matters is that if you are choosing this B as the base, you must have a corresponding height. That the height must be perpendicular. Of course, the height will be touching the vertex, the opposite vertex, and it must be perpendicular to your B. Now, this might not be a perfect diagram. So the height must be perpendicular. So if I'm choosing C as my base as well, all I have to do is that when I draw a line from the vertices, or from the vertex rather, that is opposite it, it must be perpendicular to it. Now, this may not be a perfect diagram. So if I'm doing this as well, the line must be perpendicular to these. So whatever you are choosing as your base, your height will be perpendicular to that base. So any of these guys can actually be the base, and you choose the height that is perpendicular. Of course, it will be touching the opposite vertex, and it will be perpendicular to that place. That's the first formula you know. But here's another thing you need to know. If I have the angle between two lines that are in the triangle, then I can always say that the area of a triangle is half BC sine A. So what do I mean? Look at line B, look at line C, and look at the angle that is between the two of them. Half BC sine A. So meaning that I can also write the same thing as half. So if I'm choosing AC now, that will be what? Sine B. Half A, so this is A, and this is C. And so what is the angle between them? B. So I want you to figure out the third one like that. It will be half dash dash sine dash. So you should be able to figure that on your own as well. So I said I was not going to talk about everything, but there's another one called the Aaron's formula. So area of a triangle is given as the square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Of course, what is S? S is simply the half of the perimeter of the triangle. So A plus B plus C divided by 2. So this is most likely used for cases whereby you probably don't have an angle and you cannot determine the height. You only have the side A, B, and C. Then you use this formula as well. So these are the three formulas that you can use to find the area of a triangle. But anyways, in coordinate geometry, we will still have another one as well. That one involves the use of coordinates. But for now, I'm going to limit all this for this particular class. If you have still not subscribed to the channel, that is not nice at all. So what are you doing? Subscribe now and make sure you like the video as well. I'll see you in the next one.